this is the third video of this lesson, and this is probably getting a little bit boring, if not being overkill, but I guess it's better to be safe than sorry. So here's just some more examples. This is a word problem, and so these are always freaky. You kind of got to visualize what it's asking. So we're just, ultimately we need to make a triangle out of this, because, I mean, intuitively, that's what the lesson's been on. But you'll see in a second. So the chairlift at a ski resort rises at an angle of 20.75 degrees and attains a vertical height of 1,200 feet. Okay, so just first of all, before we get anywhere, let's just say that there's this mountain, and there's the top, and maybe it's not the top, but that's as far as the chairlift goes. It has a vertical height, so meaning when you were at the base of this mountain where the chairlift started, and it goes up, it's like way above the ground, it goes up. When you were down here, you're this little person down here, this is like you're on the ground, and then of course it starts rising, the mountain starts rising, but from here, this is horizontal from where you are. And if that's horizontal, then we can figure out that actually the exact vertical height in the straight vertical direction is what is given, and it's 1,200 feet. So, here's the chairlift, whatever. This is 1,200 feet. And from a horizontal and a vertical, you always have a right angle. So we kind of made a triangle out of this mountain situation, and it's weird to think about, because like, where are we, the viewer, in drawing this diagram? Like, did we cut the mountain in half, like right here? So it's a little tricky, but just kind of trying to visualize it. And I'm sorry if my drawing is terrible. I already know. All right. So it says rises at an angle. You need to know where to put this angle. And so basically, this chairlift is from the horizontal, is rising at that angle. And so this then is 20.75. And we can label these angles however we want. We kind of made this triangle right here. We see the three sides, the three angles. There's not a really need to label them. We want to know, how far does the chairlift travel up the side of the mountain? And so basically, just how far does the chairlift go? And that's the hypotenuse. So you can just call that x, or any of your favorite variables. So we need to know which to use. We only have, this is the 90, so we have that, but we only have 20.75. So we're going to have to use that angle. That's the angle from which perspective we are using. We are looking at this triangle. If this is the angle, well, whether or not this was the angle, we knew that this over here was the hypotenuse, because it's opposite. It's the longest side. It's opposite the 90. And then from this perspective, here's the opposite. So that determines which trig function we need to use. Meaning, opposite and hypotenuse are the two that we care about. The trig function that uses both of those is sine. So we would be writing the equation sine of 20.75 equals, and then opposite over hypotenuse, 1,200 over x. And in this one, we will cross multiply, because we have a fraction. Let's make another fraction. Just get it down to one level. 1 times 1,200 is 1,200. And then x times sine of 20.75 is the same thing. And then to get x by itself, we're dividing. Those are gone. X by itself. You have basically the length of the chairlift, or how far up the mountain travels. So this would be 1,200 divided by sine 20.75. I have 3,387 feet. Well, looks like 2 F's. Okay. So again, you just got to be able to set up a picture usually, or just visualize it somehow. All right, here's another one. Okay, so this gets into a topic, I guess, angle of depression and angle of elevation. But so we'll see what that is. Boating. The Ponce de Leon Lighthouse in St. Augustine, Florida, is the second tallest brick tower in the United States. It was built in 1887 and rises 175 feet above sea level. So we can stop right there and do something with it. Here's our beautiful little sea. And we have like a lighthouse. And it looks like an obelisk, but it's a lighthouse. So you see the light. Okay. It rises that high, so we know how tall it is now. It's 175 feet tall. How far from the shore is a motorboat? So here's the shore. Lighthouse is on land, and then there's a motorboat, like somewhere out in sea. So he's out here, and this is not drawn to scale, but there's a motorboat. He's speeding. If the angle of depression from the top of the lighthouse is 13 degrees and 15 minutes. So when an angle of depression is from the top of the lighthouse, here's the top of the lighthouse. Okay, and if you just drew a straight horizontal line, an angle of depression is how many degrees down from the horizontal, from where you're at, is your angle of depression. So from how far from the shore is a motorboat? The angle of depression from the top of the lighthouse to the motorboat is that. So that's really like we're drawing a straight line to the motorboat now. And the angle of depression is right here. And we should know that 13 degrees as a decimal, 13 degrees, 15 minutes as decimals, 13. 15 out of 60, because it's 15 minutes out of 60 minutes in an hour, in terms of hours, is 2.5. Okay, we calculated that in a previous video, and day 1 does this. So this is 13.25. Now we kind of have a problem here. We are looking for how far from the shore is the motorboat. So we're looking for this distance. Like here's the shore, you know, it's where the lighthouse resides, and the motorboat's way out here. But the angle we have is not even inside the triangle. So what we need to do is kind of recall that, well, 2 things. Let's put it this way. Back in geometry, these are both horizontal lines, so they're parallel. Like they're both horizontal lines. Being parallel lines that are cut by a transversal, that means you have a line that goes through both of these parallel lines. You have something called, well, there is it's alternate interior angles. So meaning that like this angle down here and this angle up here are equivalent. They're congruent. So we would know that. We know that this is now 13.25 as well. There's another way to think about this, is if you needed to, or if you intuitively went to that direction, is that if this is vertical, because it's got to be, I mean, otherwise it's like leaning some off and it'll fall over. So this is a vertical structure. And this was the horizontal that was used to create your angle of depression. So vertical and horizontal means that this is a right angle as well. And if you know that this is a right angle, and you know a portion of it is 13.25, then you could subtract it from 90 and get this angle. So you could do that. I'm going to use the alternate interior and say that this angle is the same as this down here. Now, to solve for x, we need to know from this perspective what are the sides names that we're using. Obviously, here's the right angle. So from this perspective, this is the opposite side. And the hypotenuse is way up here, so this is the adjacent side. Right? So then you can set up your equation. This is going to be, you have to use tangent because this is opposite and adjacent. So tangent of 13.25 is 175 over x. And then cross multiply and solve. You can write it all out again. Kind of don't want to. This is tan of 13.25. When you cross multiply, it's now times by x. On the other side, 1 times 175. And once again, we're dividing by this tangent. Run out of space. 0.25. And they're gone. So x is the distance from the motorboat to the shore in which the lighthouse resides is 175 divided by tangent of 13.25. Based on an angle of depression, we get 743 feet. All right, I hope that helped setting up these word problems. Just one quick note, if it's ever asking about an angle of elevation, I guess I can quickly draw something like that. An angle of elevation would be like, like there's a person standing here, and they're really happy, and so their arms are out like that, and you got like some tree over here, and it's really good looking, and like if they said like the angle of elevation from this person's eyeballs to the top of the tree, it means from the horizontal that his eyeball makes with the tree to the top of the tree, that would be your angle of elevation. Just like depression, it goes from the horizontal, the angle of depression goes from horizontal down, and that's that, but the angle of elevation goes from horizontal up, elevate, up, right? Okay. All right, that's good.